So today we're going to talk about 2.5, and it's called the common log. Common means common, right? So this is what you'll be able to do today. Use logs to solve exponential equations. Check. Some of you already know how to do that. You're fluent in that already. And then we're also going to solve systems of equations that contain exponential functions. So very common in math is this idea of taking two things that are relatively different and we put them together. So for example, you know how to solve systems of equations. You've been doing it since really since like 7th and 8th grade, but you've really been doing it from before then. But knowing how to solve them, you can count since like 8th grade. And you just learned about exponential functions. You learned more about them in this class here, and then a couple of years ago in integrated 1. So then the last thing is, how can we use logs and algebraic reasoning to solve exponential equations? So this is our goal: solving equations, solving systems, and solving equations. If you don't understand logs, do you see how today is going to be a really difficult day for you? Okay, so just keep that in mind. Be patient with yourself as you learn this stuff, because it is a little bit on the confusinger side. Okay, so next it says, you already know that our number system is in base 10. If you didn't know that, think about why. So each of the different place values in a number are powers of 10. What does that mean, Miss Johnson? So really quickly. So when I get to, if you have like the number 243, think about the number 243. So the number 243, right? So the number 243, sorry, I'm writing up here, can't see it yet. If you think about that 243, that's the ones place. If you think about the 240, the 40 part, that's the tens place. And what's the 200? What's the 200? Yeah, that's in the hundreds place, right? Still not showing up. Man, oh man, what would I give? All right, it's going to show up, but the hundreds place could also be rewritten as 10 squared, right? So if you look at that, that's just base 10. So each place value is a base of 10. So ones is 10 to the 0. 10 is 10 to the first. 100 is 10 squared, and so on. Okay. So if you look at other number systems, like computers talk in binary code, bi meaning 2, right? They talk in zeros and ones because it's powers of 2, right? So the first place is 2 to the 0. The next place is 2 to the first. Okay. So we'll continue that in a second, but it says that makes the base 10 exponential and base 10 log functions are very important. Because the base 10 log is commonly used, it is called the common log. And to make a notation a little more compact, it is generally written without a base. So this literally says log base 10. Log base 10. That's the email that I sent you guys the other day, because 10 to the first equals 10. Log of 100, we just say log of 100. If you want to be specific, you could say log base 10 of 100, because there's an invisible 10 right there, equals 10 squared. Still not showing up. Right. So then let's continue on. So log of 10 is 1, because remember 10, 10, you guys all said if the base and the argument are the same, then it's just going to be 1. Okay, very good. Okay, it says, see how the base is just assumed to be 10 when a base isn't written. This is kind of concise notation that mathematicians love. So I either say mathematicians are really efficient or really lazy, a little of both, right? So when you use the log key on your calculator, it is automatically base 10. Some technologies like our Desmos allows you to enter a different base for a log also. right? Each of the sections below contains puzzles for you to solve about base 10 exponential functions. You will be using base 10 logs and your knowledge of exponents to find missing values for exponential functions in tables, graphs, and equations. As you're working, watch for strategies that will help you to solve equations that have variables, that have a variable in the exponent. Now, listen, there's more than one way to solve these equations, so don't get all frustrated when it doesn't make sense. I still do not have this. Oh, okay. Maybe. Okay, good. All right. So let's continue. Hopefully it'll catch up to us. It says, find the missing X in the tables. Okay, so here, this one here, I'm just going to go with this, right? It says, a tad bigger. So they want you to find the missing values of X. Which one of these was really simple for you to find? If you had to pick one of these, let's do this one first. Which one of these is easier to find? Which one of these is easier to find? Yeah, Alyssa says 100, Ms. Johnson, 100 is easier to find. So why is it easier to find? Why is that one easier to find? So this is, again, this is why I want you guys to experience these before we actually go over these. So why is it easier? Why did she say, why did you all say, why is 100 easier? Okay, so some people said because 10 times 10 is 100. More specifically, 10 squared is 100. So I'm going to rewrite this 100 as 10 squared, right? That makes sense. So then what would the X be? Very good. What would the X be then? Very good. So I got a couple of people answering. I do want to say if every single person answers, and I get everybody to answer at least twice, I give extra credit. But if it's the same people answering over and over again, and so here's the thing, guys, don't be that person. Okay, don't be that person that holds us up. Okay, just answer in the chat. No one's judging you. You could start with answering privately to me. Okay, so then what would my X be here? Oh, it would be 2. Oh, that makes sense because 10 to the second equals 100. Okay, but so what about this one? How would you figure this one out? Any ideas? Yeah, you're kind of stuck here because you're like, shoot, what do I do? Okay, and then someone said, hey, it'll be bigger than 1, but smaller than 2. Very good, very strong work there. And so because I don't know exactly what it is, can you just keep that in the back of your head of what you would do to try and figure that out? What would you do to try and figure this part out here? So let's put that right there. I know it's going to be bigger than 1 and smaller than 2. So it's going to be somewhere, but I don't know exactly where, Miss Johnson. So just keep that in mind. Everybody okay with that? Very good. Okay. So the next one, so I'm just going to move on to that. It just said, find the missing values of X in the tables. Would you know how to find this on a calculator? Would you know how to find this on a calculator? That's my next question. But over here, anybody know what any of these numbers make sense to you? Okay, so this one right here, if I rewrite this one as 3 divided by 10, hint, hint, nudge, nudge, wink, wink. Yeah, very good. So I got a couple people that says, hey, Ms. Johnson, a -1 goes in the box. And that's true because I see this 10 being divided by. And so we've talked a lot about when we divide by 10, those are negative exponents on that base, right? So then we get here and we're like, so 2 is 300. That makes sense. Well, what about this one? How would you do it? Okay, so hold off on these 3 that we don't know. Let's go. It says, when you were trying to find X and Y, when Y was 50 in the first table, you were probably thinking of an equation that looked like this. You guys all see this equation, 50 equals 10 to the x. Even if you didn't write it down, so here's your chance. Write all the equations and their solutions that were used to find x in the tables. I gave you the first one. It's 50 equals to 10 to the x. Now, what are they talking about, Ms. Johnson? Well, when you're writing your equations out, we're just translating, we're just kind of like plugging these in, right? So 50 equals 10 to the x. Okay, so can you write a couple of these equations out real quick? Go ahead and do that. Okay, so you should have gotten a couple of equations that look kind of like this, right? You should have gotten an equation that looked like 10 squared equals 100, or even 10 to the x equals to 100. For that 50, that's one of the ones that we want. I'm really interested in these equations here. So I'm going to write this equation right next to it. I should have written something like 3 times 10 to the x equals 94.87. And same thing goes right here. Can you tell me what this equation would be right here? What would this equation be right here? You can't see this right here? This one right here, sorry. I need this equation right here. Can you guys see this, where my mouse is? I mean, not my mouse, but my cursor pointer thing. Yes, that's exactly what I want. Okay, so I got a couple people doing it, so I'm gonna just snip this because it makes me happier when you all do this. Okay, so I want this equation. So that's the equation I was thinking of that goes right here, right? Okay, so I have a couple of the equations. I wrote them up here. 3 times 10 to the x equals 94.87. That's just a matter of you being able to read this table. So what strategies did you use to find the solutions to the equations that you were filling in the tables? So how do I find this? To the left or to the right? It doesn't matter. It's an equation, right? So it doesn't matter if I say my name is Miss Johnson or Miss Johnson is my name. It says the same thing, right? Does that make sense? Okay. All right, so we got a couple people giving me these equations. So then my question is how am I going to solve these equations? How am I going to solve these equations? How do I solve these? What's one of the ways that we could do this? There's actually 2 or 3. I thought of 2 or 3 ways right now. Anyone have any idea? Yeah, but how do we solve it? That's the question. How will we solve it? Okay. Someone said just kind of like plugging in for X and then estimating this is a really good idea. So I'm going to use my favorite tool called Desmos because it's my favorite tool, right? Sorry, this is stuff that we're going to do. So I'm going to plug this in right here. It says 3 times 10 to the, and then it says X. Now the number I'm trying to get is 94.87. If I'm trying to choose that one, or what number would be a good number to pick? What's a good number to pick? Now, don't give me the answer. If you already know the answer, don't give me the answer. Okay, so someone says 1.5. Very good. So I'll choose 1.5, and it's like 94.86. Hey, you give me the right answer. So this is like the perfect answer, right? So here, I'm going to put 1.5. Most likely, I don't know about you, but you won't get the perfect answer on the very first time. So what I do is I try to use my answer, my wrong answer, to figure out the right answer. Okay, so let's do some plugging in. What number would be good to plug in right here? Please don't tell me the answer. For those of you who are already done it, perfect. For those of you who didn't use the strategy, so someone says, use 5, Miss Johnson. Okay, so I'm going to use 5. And it's like 300,000. So this is where we play, like, what is it called? Goldilocks. Oh no, this is much too big. Much too big. You guys, 300,000, 150. So then what do we do with our 5? Do we keep plugging in 5? Everyone says, no, Miss Johnson. So then Goldilocks says, okay, well, let's use another number. Someone said 2.5. Okay, 2.5. And it's 948.68. Oh no, that's too what? What is that to? Do you guys ever play cold and hot? Like you're guessing stuff? Yeah, this is too small. So now you got to go like with another number. Okay, keep going. What's another number you can use? So let's say someone said, Miss Johnson, try 8. Miss Johnson, try 8. Would I plug in 8 here? If you were Miss Johnson, yeah, why wouldn't I plug in 8? Very good. Yeah, because 5 is already too high. So you going bigger, then you can assume that the number is going to be bigger, right? So goes, I don't know if you guys know this, but you guys are using all kinds of theories that we prove in later classes. So this idea of the bigger the number, the bigger the value, you're going in the wrong direction, Miss Johnson. So what number should I choose next? So someone said, Miss Johnson, try 3 or 3.5. I am not going to choose 3. Right? I am not going to choose 3 because I can calculate 3. So that'd be 1,000, right? Times 3 would be 3,000. I'm never going to use numbers that I can calculate. I'm going to go off of those numbers. So again, 3 is too big. 3 is too big and 2.5 is too small, right? So what should I use? What number should I use? 2.8, 2.7. Sure, why not? Let's go 2.8. Someone said 2.8. I go 2.8. 1,892. So no, Miss Johnson, try 7. 2.7. 1,000. Oh, yay, done. Okay, so do you see? This is kind of, I call it the Goldilocks cold, hot strategy. Warmer, 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 cold, cold, cold. It's that strategy. Not a very efficient strategy, but nonetheless, did you get your answers? Everyone says, yeah, Miss Johnson, I got my answers. Very good. Okay, next strategy. I have this graphing calculator out. What could I do with it? I have this graphing calculator. It's so fantastic. What could I do with this graphing calculator? Graphing, hint, hint on the graphing calculator. What can I do with it, guys? Yes, graph it. Okay. Graph what? What would you like me to graph? You are right. I should use the graphing hint calculator. What should I graph? What would you like me to type in here? Yeah, the function. Okay, so you want me to type 3 times 10 to the x? Yeah. I keep hitting Control V because I don't like typing all that. It's just more efficient. Right, I told you earlier that mathematicians are really efficient. Okay, fine. I graphed it, Miss Johnson. Now what? Well, I'm looking for these y values, right? So wait, what? What do you want me to do, Miss Johnson? Okay, let me show you. So I'm going to make this a tad bigger, and I'm going to find out this one. Let's just say this one. So because I want this equation, I'm looking at this equation. I have this side. I'm going to plug in this side. Y equals 94.87. Miss Johnson, nothing happened. I know, because y equals 94.87 is all the way at the top there. So, right. So let's go there. There it is. There he is right there. You guys all see it? Let's make it bigger. There he is. He's right there. What am I looking for? I know this looks really funny, but let me zoom out a little so you guys can all see. I actually have, it looks like 2 lines. It's not. See this curve? You guys all see this curve right here? Whoosh. So what am I actually looking at when I'm looking at this green and this blue, the blue curve and the green line? What am I looking at? What's the most important part here? Yeah, where they intersect, that point. So Desmos does this awesome thing, not the x-intercept. Desmos does this awesome thing that when I click on it, like kind of like this, guys all see it? Do you see that point that I'm clicking on? Hold on, let me do that. Let's see where is that thing? Let me put this away. Scoot sheet over. Okay, look at what happens when I click this. Anybody recognize anything? What do you recognize? Tell me what you recognized. If you haven't talked yet, now's the time. Yeah, it tells you the X. Miss Johnson. Look at that. Okay, so now you're going to vote. Which one is a little bit more efficient? Graphing it and finding where they intersect, or playing the Goldilocks method? Which one is more efficient? Yeah. Yes, it's way more efficient, Miss Johnson. So, okay, given the choice, do you guys all see which one I would choose? Okay. There is one more way. There's one more way. And this is written in exponentials, correct? This is written in exponentials. There's one more way that we could do this that is not graphing, that is not the Goldilocks method, but it's actual like boom. What's the other way? This is written in exponentials, hint, hint, nudge, nudge, wink, wink. What could I rewrite this in? Yes, I could rewrite this in terms of logs. Wait, Miss Johnson, what do you want me to do? So I'm going to rewrite this guy right here. 3 times 10 to the x equals, I'm going to rewrite this in logs, right? And see what happens. Actually, you know what? Let me do it with this one over here because we haven't done this one. We haven't solved this one. So just imagine this, okay? So this equation right here, you guys already came up with it, which was 10 to the x equals 50. Can you rewrite this one in terms of logs? Now, this is the key. So for those of you who are like, okay, where is she going with this? This is the part that really, really helps you. So if you can rewrite this in terms of logs, then the rest of this lesson is like, it's going to be super quick. So can you rewrite this? I'm going to pause the video, rewrite this in terms of logs. All right, so you rewrote this by logs, using logs, and it should look like this. Log of something equals something. So the first number I want to figure out is the base. What base should I put right here? What base should I put right here? Yes. So now some of you are thinking, hey, but Ms. Johnson, remember earlier you told us that we don't have to use base 10. So I'm not going to write base 10 specifically, because this is the first time that we're doing this. And I want to get you comfortable with doing this, okay? So pretend there's an imaginary 10 there. Maybe I'll write it in my like super glittery pen so that it's not really there. Okay, so log base 10, invisible 10, or just log of what equals what? What goes here? What goes here? Yes, it's 50. Oops, I'm still in my highlighter pen. Hold on. 50 equals X. So wait, Ms. Johnson, this is something I can plug into my calculator. You are right. This is something that I can plug in my calculator. So I'm going to put log. I'm not going to put a base. Notice here, it turns from cursive or like italicized to like straight log. That's how you know that this is a function, okay? So you want me to put log 50, Ms. Johnson? Yes. Just for fun, let's put log base 10 to prove to you all that this is really log base 10. See, same answers, same Z's, yes? Because these are same Z's, that means we did it. So that's my last way of doing it, is converting my exponentials into my logs. It's not the last way, it's the last way I'm going to tell you. I think the answer is 1.69, is that right? I don't remember my answer already. Oh, 1.7, geez, Ms. Johnson. Okay, 1.7, 1.69 is not as accurate. Oh, no, it is. Just kidding. I'll leave it as 1.69. Okay, I remembered wrong. Perfect. Okay, so anyone have any questions on any of this? Perfect. Let me